Mars, the red planet. For centuries, it has captivated the imagination of scientists, explorers, and dreamers alike. Our closest neighbor in the solar system, Mars holds the promise of untold discoveries and perhaps the future of humanity. But sending humans to Mars is no simple task. The journey to the red planet is fraught with immense challenges that require innovative solutions, unprecedented technology, and the bravery of explorers willing to venture into the unknown. In this race to Mars, the stakes couldn't be higher. For some, it's a mission of survival. For others, an opportunity to unlock the secrets of the universe. Yet, the journey is one that demands overcoming monumental obstacles, each one more complex than the last. The question is, how do we get there, and can we make it? At its closest, Mars is roughly 54.6 million kilometers, 33.9 million miles, away from Earth. But that distance is never constant. Depending on the positions of Earth and Mars in their respective orbits, it can range anywhere from 56 million to 400 million kilometers, 35 million to 250 million miles. With current propulsion technology, it takes approximately 6 to 9 months to travel from Earth to Mars. A journey of this length, requiring astronauts to spend long periods of time in space, brings with it some of the first and most daunting challenges. How do we keep astronauts healthy for such an extended period? How do we ensure they have enough food, water, and oxygen to survive? And what happens to the human body after months of exposure to zero gravity and radiation from space? These are questions that have no simple answers, but solutions are being explored. Solutions that may one day make the Mars journey not just possible, but safe. The human body wasn't designed for space. The conditions of weightlessness, cosmic radiation, and the physical strain of extended space travel pose significant risks to astronauts. In microgravity, muscles weaken, bones lose density, and the cardiovascular system can struggle to function as it would on Earth. Perhaps the most concerning of all is the exposure to cosmic radiation. Deep space is filled with high-energy particles from the Sun and distant supernovae, which can damage human cells and increase the risk of cancer. On Earth, our planet's magnetic field and atmosphere protect us from this radiation, but in space, astronauts are vulnerable. To combat these dangers, new solutions are being developed. From innovative spacesuits designed to protect astronauts from radiation to artificial gravity concepts that could help mitigate the physical toll of weightlessness. Scientists are also researching medical technologies, including radiation shields, advanced monitoring systems, and even the potential for artificial habitats that provide a safe and healthy environment for long-duration missions. Getting to Mars isn't just about surviving the journey. It's about getting there in the first place. The spacecraft that will carry astronauts to Mars need to be more advanced, more efficient, and more reliable than anything humanity has ever built before. The current spacecraft used for missions like Apollo or the International Space Station, ISS, were never designed for the immense distance and duration of a Mars mission. The spacecraft of the future must be capable of withstanding the harsh conditions of space for months or even years. They must be equipped with life support systems to provide air, water, and food. And they must have the capacity to protect astronauts from radiation. One of the key areas of research is propulsion technology. Traditional rocket engines are efficient for getting us into space, but to make the journey to Mars faster, we need new and revolutionary propulsion systems. One promising solution is nuclear propulsion. Both nuclear thermal and nuclear electric propulsion could drastically reduce travel time, cutting months off the journey. Other concepts include ion drives, which offer high efficiency and longer operational lifespans, or even solar sails, which would harness the power of the sun for propulsion. These cutting-edge technologies are still in the early stages, but they hold the potential to make the dream of reaching Mars not just a reality, but a viable one. Once humans arrive on Mars, the real challenge begins. A journey to Mars is just the beginning. The next hurdle is building a base on the planet that can sustain human life. Mars' thin atmosphere, composed mostly of carbon dioxide, offers no protection from radiation and extreme temperatures. The surface of Mars can be as cold as -125 degrees Celsius, -195 degrees Fahrenheit, and the dust storms that whip across the planet can last for months, blocking out sunlight and creating hazardous conditions for any mission. To create a habitable environment, scientists are investigating ways to build self-sustaining habitats on Mars. These habitats need to be airtight, temperature-controlled, and capable of providing food and water for long periods. One of the most exciting concepts is using local resources, a method called in situ resource utilization, ISRU, to extract water from the Martian soil and create breathable oxygen from the planet's carbon dioxide-rich atmosphere. Additionally, new materials and building techniques are being tested. 3D printing, for example, could allow astronauts to use Martian materials to construct their habitats, reducing the need for heavy cargo to be transported from Earth. Robotic missions will likely lay the groundwork for human settlements, preparing the land by building shelters, energy sources, and communication systems long before humans arrive. The ultimate goal of a Mars mission isn't just to visit the planet, it's to stay. For humanity to establish a permanent presence on Mars, long-term solutions must be found to the challenges of living on the red planet. How do we grow food in Martian soil? How do we recycle air and water in a closed-loop system? How do we make sure astronauts remain mentally and emotionally healthy over extended periods away from Earth? In answer to these questions, experts are developing closed-loop life support systems, technology that will allow astronauts to recycle everything from water to oxygen to food waste. Hydroponics and aquaponics, systems that use water and nutrients to grow plants without soil, will be essential to sustaining astronauts. Growing food on Mars will also allow us to reduce the reliance on supply missions from Earth. Mental health will also play a key role. Long months of isolation in a confined space, with no real contact with Earth, can take a toll on any astronaut. Researchers are already studying the psychological effects of space travel, and plans are being made to integrate virtual reality, communication tools, and recreational activities to maintain the mental well-being of astronauts during their long stay on Mars. The race to Mars is not just a race of technology, it's a race of collaboration. Private companies like SpaceX, led by Elon Musk, are pushing the boundaries of what's possible with reusable rockets and ambitious plans for interplanetary travel. Government space agencies, including NASA, are designing innovative missions and habitats, while international partnerships are fostering a unified approach to this challenge. The collaboration of minds, ideas, and resources is essential if we are to overcome the monumental obstacles in our path. The journey to Mars will not be a solo endeavor. It will require the combined efforts of scientists, engineers, astronauts, and dreamers from all corners of the globe. In the end, the solutions to the challenges we face in the race to Mars will not only bring us closer to the red planet, they will pave the way for a future in which humanity can reach beyond Earth, exploring the cosmos, and perhaps even one day becoming a multi-planetary species. The race to Mars is no longer just a dream. It's a mission in the making. With every technological leap, every scientific breakthrough, and every brave step forward, humanity draws closer to its destination. Mars is waiting, And the question is no longer, can we go? But how soon? The red planet beckons, and humanity is ready to answer the call.